back on and do a demo, walk through. Mine said the recording just started, so did you just start it, Lucas?
Yeah, we had Evan started.
Okay, do I need to go through any of the preamble, or is that good?
No, that's okay.
Okay, so again, I'm going to start off with go through the documentation, talk about how it works, and answer some questions if there are any. Then Luke's going to jump in, go through some slides. Then I'll do a demo and show you guys, more importantly than me doing a demo, which is only of so much value, show you guys how you can do the demos yourself and set that up so your customers, because that's what's most important, is you be able to demo, talk about this to your customers who are already using SQL Server and say, hey, we'd love to take you through the cloud and show you those pieces, but if there's pushback or there's other reasons why you do it on-prem and inside the SQL Server, you can demo to them and show them how you can enhance these capabilities right there. And then Lucas, again, will come back on final with his own demo and kind of talk about how those pieces work together. Does that make sense? Any questions before we get started? Okay. We'll jump right into it. So I do have a large number of slides and slide decks that I retrieved from various places inside Microsoft. The trouble, as you can see on a lot of these, is they all say Microsoft Confidential Internal. I don't know why all this stuff's public, but for whatever reason, I can't share the direct slides with you. But as you remember from 2 months ago, we don't need slides. We don't need no stinking slides to make this work. So we'll jump right into the actual docs, right? Now that we have docs.microsoft.com, I hope over the last time you really started to use this as a great tool across all the different services, but certainly on the data and AI side, we're trying to pump this up with all the information you need, basically the same left side structure, so you can kind of get used to it and know that, hey, there'll be samples, there'll be way to quickly install things and all the tutorials to help me get going. So with that, we'll jump right into, hopefully under docs.microsoft.com, you can find SQL Server, and then quickly you can find Machine Learning Services under SQL Server. So by way of historical perspective, Microsoft several years ago purchased a company, Revolution Analytics. And so Revolution Analytics had one capability that was really, really impressive. It had multiple, but one that was super impressive and relevant to the topic at hand. And that's called R Server. And so as R became a very, very popular language in the data science realm, we know that a lot of packages and a lot of third parties, colleges, professors, as part of their publishing requirements, et cetera, were writing packages to R to be able to in the system called CRAN, to be able to publish those and for people to be able to download them and use those for EDA, data analytics and analysis, to a lot of statistical functions, et cetera. The problem with R, and the problem with R still remains today, is that even though it's an open source tool, it is very limited in memory bound. So it doesn't chunk really well to disk. It pretty much uses all the memory you have, but when you run out of memory, it doesn't degrade gracefully and figure out how to do things. Secondly, it doesn't parallelize very well. So you can send it one query and it does some pretty impressive things. But again, on small data sets, on data sets that can fit on your laptop, it's awesome. Again, if you have enough memory on your laptop to hold those data sets, awesome. Outside of that, it starts to really break down. And so Revolution Analytics deployed a product called R Server, which basically took away those two limitations by taking the open source R packages, adding a slight extension to them so there would be minimal code changes, but parallelizing them and chunking them under the covers so that the R programmer would know no different, but be able to talk to much larger data sets. And so quite often is the case, we still use what's called R Server when we do Spark implementations. And if you're familiar with Databricks, something we're coming out with that's just recently, matter of fact, a few days ago, I think went GA, but very, very important technology and the big data side thing. I hope, maybe at some point we'll have that conversation as well, all about Spark and Databricks and why that's so critical to everything we're going to do from a big data standpoint. But because it's big data and you need to analyze it, a lot of implementations have R Server, the historical R Server, sitting in the cloud, accessing a Databricks or Spark cluster to be able to run against it. And again, it thinks it's all on its own machine. It doesn't necessarily know it's being parallelized. That query it just sent out is being sent across the Spark cluster. It just thinks it's sending it out, which is an ideal scenario. So fast forward a little bit to today. Obviously, R is still a very important language, probably more so in academia than in the consumer space today, but still a very important language and growing. However, Python has taken over as probably the de facto language of choice for machine learning, artificial intelligence professionals. If you look at libraries like Keras, TensorFlow, CNTK from an artificial intelligence standpoint or deep learning standpoint, all Python is the primary language. Again, there's interfaces to R and other things, C, but you're always trying to step through it to get back to Python. I won't tell you the pluses and minuses of Python. There's certainly plenty out there, but just enough to say that Python also suffers with some of the same. Not exactly, it doesn't degrade as horribly as R does in some of those environments, but it certainly is expecting most data structures to be in memory. It's when it does a sum or it does some type of attribute aggregation, it does it with the context of all this data is in memory, and so my pointers. When you get under the covers, right, my pointers are actually accessing memory locations. Therefore, I can rapidly achieve this aggregate. Not necessarily so when you have it sitting on a cluster somewhere. So there are tools and processes and libraries underneath Python that will help alleviate that. And Microsoft has released a lot of what we used to call R server into something we now call machine learning server, which includes both R and Python modules to be able to do that. So all that being said, that kind of brings us to SQL Server machine learning services. So because those servers now can run on-prem or in the cloud, it was a natural logical extension to say, hey, if we have this code and this parallelizing code and this chunking code for large hunks of data, let's not just keep it as a Python library, but let's infuse it into arguably the largest data system in the world around Microsoft SQL Server. You could argue Excel is actually the largest, but second largest outside of Excel, being the number one data store, is SQL, and certainly Microsoft SQL Server is the largest of the SQL implementations on the planet right now. Now that could change over time with MySQL and some other things, but right now Microsoft SQL Server is by far the largest. So why not infuse all that learning we've had about parallelizing, chunking, being able to run machine learning models and structures right into the SQL Server. And some of the huge advantages of that too is it gives us much faster time, fast time to insight, right? So you don't have to necessarily pull a bunch of data or sample the data or determine what's the flow of the data back and forth out of SQL Server. You can do it right inside SQL Server. So from a milliseconds, nanoseconds almost type processing, for some real-time environments, you might not want to call something else that then jumps around and then goes into SQL Server, pulls some data, looks at it, does some more analysis, goes back into SQL Server to do things. Again, very, very fast systems, but when you're talking about as a piece of the puzzle, prediction as a piece of a larger puzzle of what you're trying to solve with the application, it just adds time to it. So why not do it right inside the database? Also, from a collaboration standpoint and sharing things, if you have the models inside the database, if you have the code running right inside stored procedures in your database, then guess what? You don't have to worry about a whole lot of external third-party tools for people to be able to share and look at your data, right? We have everyone that has security ACLs can access that stored procedure, look at it, determine what's going on, make sure it's right. Help version it and understand it through some of the other source control capabilities, but everyone has access to it right away. So you don't have this model that I got to figure out how to publish that so everybody can see it, so people can modify it if they need to, all built inside SQL Server. The last piece before I'll jump back into docs is really about deployment. So yes, there are some deployment pieces, and I'll walk you through that in the demo, in the example of getting it. But it's really a one-click, one-step process, as Lucas showed you last month, and again, he did a very good job. But it's a 6-step process, and things can go wrong in that. And there's reasons why it's 6 steps, because you can alter things at each step. There's things you can do. It gives you a lot of flexibility and power. So we don't want to diminish that. However, the capability of saying, hey, we just want to deploy this right inside the SQL Server. Everybody knows where it's deployed. Everybody understands it. It's basically 1 or 2 click deployment, and it's up and running inside your server. Makes it very valuable. So that's kind of the bigger picture before we dive into the docs here and dive into some things. Any questions on that before we keep going? Okay, great. Feel free to stop me anytime. I'll keep one eye over here on the conversation window. If anybody puts something in the text, I'll try to jump on that as well. So again, lots of slideware. You can provide lots of slideware for your clients. More importantly, to jump into docs and actually walk them through it. So if you get to docs SQL and then SQL Server Machine Learning Services, you'll get to the page I believe you're seeing right now. And again, you can start to see some things that we talked about, right? So we talked about SQL Server Machine Learning Services in database. And again, that was taking that R server that became Machine Learning Server and then infused those capabilities directly into SQL Server, so in database, as well as Machine Learning Server standalone. So if you're working against non-SQL Server clusters or other capabilities that you need outside of SQL Server, we still offer those same modules and the time it takes to write those. If someone says, hey, we have most of our data in SQL Server, but we have some things in MySQL or Postgres or even a NoSQL structure like Cosmos DB, you can still take those pieces of code you've written and deploy them in SQL Server Machine Learning Server standalone. And again, it's a SQL Server setup, but it's really decoupled from SQL Server. And again, what's really important about this, especially these first 2 packages, and the other ones add value, no doubt about it, but the RevoScale R and the RevoScale Pi, and again, these libraries are what's really the kind of the heartbeat of everything we're going to do inside and outside SQL Server. These are R Python libraries, again, from Revolution, that's why they're Revo. And it really gives that scale, right? The ability to chunk data, the ability to parallelize algorithms inside the database. So again, these are running inside your database, and we can look at actually the services on your PC to see how they're running inside your database. But they're actually services that are always running in the background and able to help and scale that for you. So as you go through this, you'll see a bunch of use cases, and pretty much everything will have an R or a Python path. So again, if you have people or customers that are more familiar with R, feel free to take them down that R path. I would suggest if you're equally knowledgeable or not knowledgeable or have a desire to become knowledgeable on any one of these, I would suggest sticking more with the Python route. I think that's going to add a lot more value to you. Again, we'll talk a lot about setup. I think Luke's going to talk about setup as well. But really the heartbeat of this is this SP execute external script module. And so we'll have some things about how to make sure that's turned on during implementation because it's really critical. When that's turned on, that allows it to access that external service that's running in the background that has Python or a Python or an R environment running inside it that allows it to run right inside your server. Again, you can kind of go back through the history. You can see SQL Server R server standalone back with 9.1 was a big enhancement. And now you can kind of see as we move forward what those are and all the documentation, etc. A lot of great tutorials. I'm going to walk you through some of them, but only a couple. There's many, many more. Again, as you start to get your customers interested, thinking about working through some of the things in Python or R inside SQL Server, I encourage you to look at several of these. They may be more advantageous. But from an architecture standpoint, you can, again, walk them through all the different pieces of how this works inside in database and standalone. And again, it's really the RevoScale Pi or the RevoScale R that's really going to change kind of how everything works. But if they have questions about security and understanding, hey, this all sounds great, but I don't want other services running on my box. I'm worried that it could be a security hole. Someone could tap into those and somehow break into the SQL Server itself. There's great things in here to talk about how the execution works and what the process is. So if you have any questions about security, which is always with customers' data, something that comes up, very important to at least understand what's kind of going on here so you can help them understand how everything works back and forth from the SQL Server processes all the way out to the BXL server processes and kind of how they talk back and forth to make sure that everything's working correctly. So again, I think Luke's going to cover some things about the install, but some of the things I will talk through going forward is the Python. And again, using it both in T-SQL outside of the database to call into the database, as well as inside the database itself to work through that. So with that, before I get into my demo, I will turn it over to Lucas to cover his pieces of the puzzle, and then we can jump into the demos.
Okay, great.
And while he's getting that set up, if there are any questions on that first part before he gets going? Okay, no worries. But again, just please be thinking about this and churning it in your head, because your customers are using a lot of SQL Server. You guys are great at SQL Server. That's what you guys knock out of the park. Let's just kind of keep expanding, extending, thinking through that. So, okay, thanks, Lucas.
Great. Yeah, you're welcome. Thank you, Chris. So to recap, SQL Server Machine Learning Services has a in-database and standalone version. There was a 2016 release that included R, and 2017 included Python. So to start off, the installation of this is similar to other features that are available with SQL Server. And as you notice, there's a in-database and a standalone database for the machine learning server. You can install either R or Python or both at the same time, and the selected language files that you have selected will be required constant to download and install on your server. Once installed, there's a few post-installation steps required for configuration of the Launchpad service. You need to enable external script in order for the SP execute external scripts process to be executed. Some security concerns, like Chris was discussing. Most things can be blocked by using a firewall. Another thing is, right from the get-go, any users need to be authenticated. Any authenticated Windows users need to have permission to that database. So they must have either DBA read, DBA writer, or DDL admin, and each user needs to have a specific execution of grant execute any external script to their username in order to execute that stored procedure. You can also use SQL logins whenever the compute context is switched to SQL Server instead of local. Also, during setup, a new Windows user group will be created, and this is primarily used for running tasks under a specific security token of the SQL Server Trusted Launchpad service, which we'll talk about more a little bit later. When a user sends a Python or R script to or from their laptop, SQL Server calls upon one of these worker accounts and maps their identity to that calling user. This type of security model is called a implied authentication, and it's baked into the database engine to provide that secure execution of those external scripts. The group name is called SQL R user group, and by default, it creates 20 worker accounts. And another thing to be aware of is currently there's no transparent data encryption, and always encrypted databases are not supported, mainly because the external runtimes don't have access to those encryption keys. So the architecture, the SQL Server EXE is the one EXE that runs all SQL commands. And for this external process, whenever the SP execute external script is called, it calls into the Launchpad exe. The SQL Server Trusted Launchpad. That is similar to the way full text indexing is done by calling up a query service and hosting it in a separate process. The Launchpad will then call into either a R launcher or a Python launcher. The R launcher will call out to R term, which is the terminal interface for working with R. Python on the other side is just a regular Python exe. Then both of those will communicate with the binary exchange language server, and that's something that was developed by Microsoft to communicate, to allow communication between R and Python. There's also a SQL Server platform abstraction layer, and this is designed to allow the operating system to be platform independent, so it could run on any operating system. This was created out of the Microsoft research project called Drawbridge, and it leverages the SQL Server operating system in the back end. One thing that we'll look at in the demo today is extended events. So we can hook up, regular extended event that we're used to into this binary exchange language server and see all the different communications, connections, and data being transferred. Once that command gets to the binary exchange language server, it then passes a command to the SQL satellite DLL, and that's a extensibility API written for SQL Server 2016 to provide database engine support for executing code and runtimes written in C or C++. And so one thing about R and Python is they're languages that then compile down into native C and C++. So the SQL satellite just takes that code and is able to efficiently and optimize it for data transfer back and forth between SQL Server. It also does type conversion and schema definition, at runtime. So it handles a whole lot of things for you behind the scenes. So before the demo, we're going to look at some custom management studio reports that have been developed by the Microsoft team. We'll also take a look at some DMVs, extended events, and the resource governance. So here I've got a SQL Server virtual machine running in Azure. Here is the Launchpad service that's currently running. And to show you the SQL R user group and all of the different user accounts that get created.
Good question, Lucas.
Yeah.
Is it possible to increase the number of those accounts to potentially parallelize your processes even beyond the upper limit of 20 that we can see here?
Yes, it is possible. Microsoft found that 20 was pretty sufficient for most of their customers and could handle, a lot of the workloads that they were seeing. But yeah, you can definitely increase that to however many you need.
Okay.
And do each of those represent a thread? Like, is that for parallelization, or are they parallelized within each user group, within each user, not just the group?
I believe they would be parallelized per user.
Okay. So it's not like 20 threads that you're calling. It's 20 user accounts, which then can call multiple threads from that account.
It is multiple threads that can then be parallelized.
Cool.
Yeah, the trouble is if you have two. I'm sorry.
We'll see an example of that. Go ahead, Chris.
Okay.
Yeah, the trouble is, as we all understand from basic computer, we start to have thrashing if you have too many. So a lot of times people think, oh, I can parallelize this, I can parallelize it even more. But again, we're kind of CPU bound, so there's a lot of thrashing on that. As we look at, there's some other pieces and some other ways to do GPU execution, so we can pull things out and push it to that. But most of the time, our 20 would be more than sufficient for what you're trying to do. If you try to do more than that, your performance will degrade. So,
speaking of that, what are the considerations for server memory, compute, and even the subsystem when standing up and using machine learning services or server?
A lot of what I see is RAM is definitely important. This VM itself has 32 gigs of RAM, and the example we'll see will actually push that limit. We'll use at least 20 gigs to complete just a basic process.
Okay.
CPU-wise, the more the better.
I mean, is there a recommendation from Microsoft on what kind of like minimum or recommended?
I can look through the docs. I don't remember seeing an exact minimum, but yeah, I mean, you have to obviously have the SQL Server minimum specs.
Right.
And like Lucas said, RAM. The trouble is anything that, because it's so varied depending on what you want to do, number of columns, features, how the models work. It's pretty wide swath of you have to test it against different architectures, and so I can look around through the docs, but I do not recall an exact minimum.
Okay.
Yeah, that's a good point. I would go by the minimum being SQL Server, like you said, Chris, and then after that, it would be based on your project.
Yeah, in my experience with trying to do this kind of stuff, it's been so widely varied based on not only data set size, but also workload on that data set that a true recommendation can't really be made until you fully understand what you're actually doing with the data.
Okay.
Which is kind of a cop-out answer, but still.
Yeah.
It's okay. Thank you.
Yep. So first, here is our data set that we're going to look at. It's a loan stat table. It's got 1.1 million rows, 145 columns, and we are running on SQL Server 2017, and it's a Windows Server 2016 data center. Just a kind of a quick glance at some of the data here. Mainly numeric, some string characters in there. But we'll look at the custom reports for that was developed by Microsoft. They're located out here on GitHub, and there's a number of them, and very, very well documented and very well put together. In order to open one of these up, we can right-click on Databases and go into Report and Custom Reports, and then you can open up directly from there. Some of these take a little bit of time to run, so I've gone ahead and preloaded them on the side over here. So the first one we'll look at is Machine Learning Services Configuration. This report will show you, which runtimes have been installed, is your external scripts enabled, and is implied authentication enabled. Plus, it gives you additional information about your R and Python environments and the versions that are available, plus libraries and paths. The next one will show you a list of all the packages. So here we've got 79 R packages installed and where they're at, plus their version and dependencies. And then if we scroll down a little bit, we can see there's 128 Python packages installed. So we can get a list of libraries and packages very quickly using this report. The next one is resource usage. So currently we can see that there's been the peak memory usage was at about 20 gigs. The current memory consumption, the OS is taking up quite a bit, and SQL Server is taking up a little. You can also see the max memory settings for your resource governor, CPU usage per hour, and your statistics. The next one is execution statistics of the SP execute external script. It'll show you how many errors have happened, how long that that stored procedure has been executing, and plus what counters are being ran. So I've been running the RxD Forest, which is part of the RevoScale R package, and the RX Predict for the decision forest. This is another script that will allow you to just copy and paste to enable the instant setting. And I haven't refreshed this, but this was one from earlier today, showing current active sessions that are running either R or Python, and this is one from this morning. And then this is a list of all the extended events possible for the new machine learning service. And there's quite a bit, and we'll look at a good majority of these today. So, like I was saying, here our data set that we're going to work with here in a little bit. So first, we want to look at our resource governance. Located under management. And as you see, we can create, the standard resource pools. We can have workload groups assigned to specific external resource pools and allocate their memory accordingly. Now, to demonstrate this, I've got this the default set to 5% of the maximum memory. That's to show this next process called plot distribution, and it will fail because it's such a large process that it's trying to take up as much memory as possible, and being kind of constrained with this 5%, it should error out in about 12 seconds. So see, it says, I'm sorry, but I can't allocate any more bytes. So it's running out of memory. So we can up this for the resource governor to 60%, and that will free it up to allow to run efficiently. For the external resources, this is also, it can also be set up to run for specific applications. So your Microsoft R host or RStudio, we can define a function for the resource governor so that anytime it sees RStudio or Microsoft R host, it'll automatically switch over to use that external pool. We'll go ahead and set that. Next, we'll get into reviewing the Launchpad. And so here we've got the regular SQL Server instance Launchpad, and it looks like we've got some R term running. So we want to kick off this basic execution of a Python script to show the Launchpad starting Python, the console host, and then that binary exchange language server. Not in the right context. And there we see Python got kicked off, and now it's processing to retrieve that data. And then there goes the DXL server, and then you saw a couple of that one got released. And so then that was the data that we wanted to return from the Iris dataset. So we've increased that maximum memory to 60. When we execute this plot distribution, it's going to take about 5 minutes. So before I do that, let's review the extended event. So I've got two extended event sessions here. We'll go ahead and open them, and we'll start watching the data there. And to show you some of the properties that we're taking a look at, is I've got when the launch pad gets started, when it resumes, anytime there's anything that happens with the satellite, any errors or cleanup or data sent. And the nice thing about extended events is you can also come in and configure each one of these to return specific parameters or events that you want to capture. Just to set up real quick. So in order to see this quickly, let's run that iris data set again. Notice Process Explorer ran the Python, and now we're able to capture those events. So here's the data chunk that got sent over. We can see, yep, there's the database name and there's the SQL text. And if we scroll up some, we can see that message size was 28. There was one for 56, 368. We can definitely monitor and see, what's going on behind the scenes. If we run this plot distribution, you'll notice that a whole bunch of R terms are now starting to get populated. Maybe 60% was not good.
You didn't actually confirm it. We'll open it back up.
Good. Now we'll run that again, and we'll notice that the R term will start consuming a lot of memory. We'll also see that the number of events are going up quite a bit from all the data that is being moved around. And so, seeing what memory grow as well. And yeah, there went another large chunk. And so what this is doing, take a look at the actual script. It's bringing in all of the loan stat data, the 1.1 million, creating a temp directory called plot, and creating a JPEG to print out all the distributions for all of the numeric columns that are in the loans data set. That is then melted together using the R-Shape2 package and comparing it with the is-bad predictor column. That's then printed out to that file that we created earlier. Here's a few that I had ran this morning, but to show an example of what got created is this here. So for each one of these grids, it's comparing the 1.1 million rows against another set of 1.1 million rows of the is bad factor, and then plotting that to show how they correlate, which can then be used for feature selection. And the ones that are here in red would be good for continuing to feed into a model to see about how well it would perform. So since this is getting kind of large. I'll go ahead and close that one. I'll free it up. We'll stop that. There we're up to 21 gig.
And is that because of the 60% of the whatever percent that people's taking up? Limited by that?
Correct. Yeah, we could have increased that to 100%, and it would have taken all resources possible.
With all resources that can be allocated to SQL Server, right?
Correct.
Okay.
So, as you see, SQL Server is really only running at 2 gigs. Our R term is at 6, and that binary exchange server is running at 7. So there's quite a bit of communication back and forth and a whole lot of processing in the R term. And this is just using the native packages for R. If we use some of the RevoScalar packages, that would parallelize this even more and improve performance considerably.
Okay, Lucas, anything else you want to show on there, or can I bounce back? Or?
Yeah, sure. Yeah, that was my whole demo.
Any questions on that before we jump back to? Okay. Great. So tell me when you can see my screen.
Yeah.
Lucas, can you see it?
Okay, yes.
Yeah. So we might went a little out of order there. Just I'm going to talk a little bit about the overall and do a demo on the overall piece. And obviously, Lucas was talking about more of the advanced. If once you're into it and you're trying to debug or figure out memory allocation spaces or extended event logging, those are great pieces as well. So just by way of helping you understand and being able to demo this to your end customers as well. Again, going through docs, etc. And one other thing before I do that, because I don't want to forget it, if you go to academy.microsoft.com, which again is not the same thing as Microsoft Virtual Academy, sometimes it's confused, but academy.microsoft.com, you'll see basically the professional programs that we offer. And we've had data science for a while. That was kind of the initial one. I know myself, Lucas, Evan, I'm not sure if there's anybody else that has completed that yet, but that's there. And so that's able to be completed by anyone. The big data one, I think I still have 2 more classes in that because I jumped over. We had kind of an alpha going of this thing called the artificial intelligence MPP. And so it says coming soon. We've been told internally this actually comes up Monday, so April 1st. This actually comes live. There's 10 classes. Some of them are pretty straightforward. Some of them are complicated. The first class, Introduction to AI on edX, I would ask everyone inside Microsoft, and certainly everyone inside Kaizen, to go through. You can do it in a week or less, but it's it really has a good smattering and understanding of all AI capabilities. So not relevant to this specific conversation, but just because it's coming out Monday, I wanted to make sure I alerted you. It's a pretty important piece of the puzzle. So when we go through the Python, again, when we go through the SQL Server Machine Learning Services and we kind of drill down through the Python tutorials, one of the tutorials you'll get to in GitHub, the GitHub account, is the rental prediction. And so this is a great piece of the puzzle to help you understand step by step exactly what to do to set up your environment. So if you're unfamiliar with how to do different things, you can set up everything here, how to set up SQL Server Management Studio with links to everything you need to do here. Again, as Lucas talked about, kind of one of the most important bugs that most people run into is they don't have external scripts enabled. So you're making sure that's kind of enabled. And then talking about the IDE, and again, you can use PyCharm or Spider or others, but the ones most of us use is either PyCharm or VS Code. So it has all the different steps to set everything up there, and then you proceed to step 2. So I'll just show you how I did the rest of this tutorial is in, well, I'll show you in, sorry. I'll show you in, so in Azure, if you do create resource and you do deep learning virtual machine, you'll see here that this is really, it's a specifically configured variant of the DSVM, and it's got a lot of GPU horsepower. So if you're doing basic DS features, feel free to just use the DSVM because it's not going to have as much GPU enabled on it. But certainly when you get to the deep learning stuff, you'll want to do the GPU base. But basically, if you're showing someone this and you're just trying to pull up a quick environment to show them, and you don't want to install SQL Server, Personal Edition, you want to install the Python packages, you just don't want to install that stuff, you want it kind of out of the box just to work really quick to show someone, then pick a DSVM or the deep learning VM, and it will already have kind of all this stuff that I'm getting ready to show you built in to it, so you don't have to rebuild that each time. And again, you guys can create your own VMs and save those to if you as a company decide, hey, these are the ones we want to show people. Okay, so for this particular, again, there's the basic environment that's set up, and then there's the creating your script in Python. And so this one uses kind of ski rental business just to make it easier instead of having to run all these scripts to load the data. They basically have a back file, so you can just basically drop this into your backup folder. I had to change this to 14, but everything else works exactly the same in my environment. So basically drop this backup file here. Then opening SQL Server Management Studio, able just to kind of plop this in. Again, had to change these to 14. Just beware, depending on what version you're using, make sure you use that the right one. Really only using 13 and 14. If you go below that, things probably aren't going to work the way you think they are. So be really careful on that one. But there's theoretically some things you can do there. And then jump down and basically just using that kind of helps you understand kind of what's in that data structure already. Tutorial, or it's called what's it called? I can look in SQL Server Management Studio just a second and see. Oh yeah, it's called Tutorial DB. That's right, Tutorial DB and the log file, and you can kind of look and see what's inside that. So in this first pass, and again, number 2, create your ML script, this is really as if you are an outside entity outside of the SQL Server environment, but still wanting to use some of the SQL Server packages like RevoScale R, RevoScale Pi, etc., to be able to do and accomplish what you're trying to get at. So again, sometimes these packages will exist outside of SQL Server, and you need to call and pull the data either on the same machine or sometimes even across the web. So what this is basically you can just kind of copy and paste this into your, and I'll show you really quick. So this is the data science, again, the deep learning data science VM that I've created. You can see here I'm using SQL Server Management Studio, and I've loaded under 14, I've loaded the tutorial DB. So that's pretty straightforward there. And if I want to run a new query against those, I can. But I've also loaded underneath VS Code. So the first thing you want to do is you could go in, and I think it talks you through that as well, loading the Python editor and make sure you have all the Python pieces kind of loaded in here, all your lints and everything. So in that, basically all I did was cut and paste the code from here as it went through each section into it. So you can just hit copy. One thing to worry about this too is I copied, but I didn't get the last line when I just kind of grabbed it and copied it. And took me about a half hour to debug what was going on. So always just make sure you hit copy so you don't accidentally screw up and not get that last line and not getting the results you want. But as you kind of go through this, you can view you're going the right direction like any good debugging system by just doing snippets of the code at a time and making sure you're coming up. I believe in this I was getting 10 columns, so I think the data changed because I got the right number of rows, but 10 columns in each of these. So when we do shapes and other things in Python, you'll see, certain things will have 12 rows and 453 rows, but they'll have 10 columns. So don't be alarmed if you see the column counts off on some of those. Seems like the underlying data has changed. And again, here you can see kind of the results are shaping of the data of 10 versus 7. But you can read the comments in here. I don't really like Python as a language, but at least the examples seem to be pretty well. It's a very readable language, and certainly it's very commented most of the time. So you can figure out what's going on. I have to admit my C# stuff's not super commented as well as it should be most of the time. But this is really well. So copy them all down, and you'll end up with this script. Oh, sorry. You'll end up with this script in complete, and then you'll be able to just run it straightforward right there. One thing to note, though, is because this runs in the Python that's installed with SQL Server, which is different than other environments you have on your machine. So if I do cd:/code, which is where I actually have the code, and I look in there and I say, hey, standard plot.py. So here, if I do Python standard plot.py, it errors out, and you can see it errors out by from RevoScale.py. So I don't have, and I can't really pip install. I can't pip install. Oh, sorry. RevoScale.py. The same way I can other packages, because again, it becomes SQL Server and it's built into some of the things. So it says, collecting it, couldn't find the version that satisfies its requirements. And so because SQL Server has it built in, you have some of those. There's ways to get around that, but most of the time you want to make sure you're in the context of, if I have to, I'll switch to the context of the Python services, like Lucas showed you. Everything kind of runs underneath this Python services. And then you can run whatever code you want, because it will, if I did a pip list here, it should, if I did pip list here, I should be able to go back to well, I don't see it. I'm probably running this still in the same context yet. I'm not running in this context local. So, but either way, you understand that because there's different environments on your machine, you're going to make sure you're executing in the right environment that's running inside that. So, very good. Okay, so that's that. And again, it walks you through basically creating the model, saying what it is, training, testing it, and then running it, printing it out. You can see back up here. It printed out all the predictions, and it gives me a computed error. And again, these errors may be off of what is still e to the minus 27, so it's a very, very small error. But it may be off of exactly what you see in the documentation, because again, these are shaped to 10, and there's some slightly different. There are 453 this training test. Even though I did the same seed, it didn't come out with necessarily the same exact result. So, but don't be alarmed; it's still coming out with the right result to show you what's going on. Okay. So with that, oh shoot, I know we're way almost out of time. Last thing I'll tell you real quick is, okay, so you go to step 3 then, deploy your script to Microsoft SQL Server. And again, at this point, you're just in SQL Server, so just copy these. It'll kind of go straight down. They're all basically drop procedures, create procedures, and it's pretty straightforward until you get down here where you actually have the script. And again, copy it, and it'll have all the steps of exactly what's going on. And when you do that, you will be able to get to this working pretty well, where again you can kind of copy and paste each of those pieces into basically, we create a new query, execute the query, and I'll just do the last one just to show. We don't have time to go through each of them, but if I just grab this last one, copy it, and then paste it in here and execute. Assuming I've set up everything, I think I have it. Yeah, sure enough, here it is, the D-tree model and the linear model, comparison between the two. Again, these models now are stored inside SQL Server, and you saw how fast it executed. So like Lucas showed you, there's a lot of constraints or things to think about, but the benefit of this versus the Python code I showed you earlier was, again, it's time to pull that data out of SQL Server to do everything. In this instance, it's running right inside the SQL Server context, and the models are deployed inside SQL Server. So again, we had the retail account prediction. The actual rental count, 38, 29.5, et cetera. You can go back and forth and you kind of compare those models. A rental count 445 versus 556. You can kind of start to see the second model. The linear model seems to be a slightly better model at predicting what's going on. So again, I don't know if this is Louisville Power and Light, whatever it is, whatever customers you're dealing with, they're always trying to say, especially from a BI perspective, what does yesterday look like? And if they can think about what yesterday looks like and help them make decisions today, we can predict things in the future because we already have data at the right granularity, and then we can do this right inside the database. So I hope you consider this strongly as a possibility when you're talking to your customers and clients about something to go forward with. So with that, I'll pause, Lucas. I apologize. We didn't get our timing exactly right, but we're right at the end of the time. Any questions here before we log off? Does that make sense? Does anybody think they could use this or kind of talk to some of their customers about this?
Oh, yeah, definitely.
Awesome. Okay.
Anybody who's...
I'm sorry?
Do we have anybody we're talking to currently that is thinking about doing something?
World Meds.
And
Okay.
me.
Okay. Well, yeah, let's keep the dialogue open and new ones. Like I say, every customer you have that has SQL Server, certainly ones that have upgraded to 16, 17, we're right on the path. If they're planning on upgrading or if they want a reason to upgrade, again, these are all great things to have those conversations and dialogue with. And we might or might not be able to get something into April, but certainly in May, I think we've been talking a little bit about possibly doing some Keras stuff or some other deep learning algorithms, kind of take this to the next level now that we've done base ML and now kind of taking that down to SQL Server and on-prem products to now kind of go a different direction towards the AI piece with some of the deep learning models. So possibly if there's other topics as well, you guys can kind of talk about that and see if there's something else we want to talk about. But that was what we had originally thrown out there as possibly the next scenario.
Yeah, that sounds good. Chris, I know you could present. Would anybody else like to present?
Or if there's a topic you guys are really passionate about, doesn't have to be anything about this stuff, or you guys are doing some cool stuff or learned something cool you want to show, those are great things as well.
And it could be any technology. Tabular models or Power BI or...
I'll probably have something in the not too distant future that I'd like to share about Power BI, but I'm still trying to come up to speed on that March update. They've changed like 80% of the end user experience with that update, though. Once I'm able to really sink my teeth into that, I have a feeling that I'll be wanting to share some of the cool stuff they added.
Yeah, that's obviously a technology everybody can use and everybody understands. So it's a lot of sizzle in that. So if you'd want to do next month and that, and then again, Slava and I had talked about doing some Keras stuff or some deep learning stuff after that. Whatever you guys want, I just want to let you know I'm available, capable, and we can knock it out. So.
Yeah, I will. I'll reach out to you when I feel as though I have at least a topic that I'd like to dive into.
Cool. Okay, yeah, this is a great, right? No judgment environment. So if you mess up, hey, it's great to mess up here and not in front of the customer and learn through a couple different things, and then you're ready to roll when you hit the customer. So, okay, thanks everybody. I definitely appreciate it.
Thank
I'll
you.
talk to you guys soon.